Hello everyone, my name is Jaebeom Kim and I work as principal researcher as well as the manager of TTA's FinTech laboratory. This is an honor to be able to play an active role in one session of Authenticate Virtual Summit, the APAC Innovation for Next Generation on Fingerprint Testing. Because of the COVID-19 pandemic situation that we faced, my presentation will be held online, but I will be as interactive as possible. You might have some questions about my presentation. If so, please just stop by the TTI's virtual booth or send me an email. My email address is listed at the last slide. My presentation is all about the future, specifically the future of biometric testing. TTI is evaluating the recognition and presentation attack detection performance of biometric devices, as well as the security of biometric devices using current technology and standard. But today's discussion is all about the future. I'd like to discuss all biometric modalities, but the conference organizer didn't allow me to do so due to the time constraint. Actually, I'm relaxed that I only have this one short session because I finished this presentation slide a few minutes ago. This is my excuse, but it's difficult to create a presentation slide while performing routine tasks. I record my presentation on lessons learned and future tasks as a PIDO certified laboratory at the last plenary meeting. And the presentation at the time was more focused on the fundamental concept of biometric testing and evaluation, and also about the face recognition technologies. So, today I'd like to talk about how to go about testing and evaluating fingerprint recognition devices, specifically the future methodology for that modality. Of course, my presentation today will only cover the broad outlines, and it will not be perfect. Even so, I hope that this brief presentation can help to prepare future of the testing and evaluation for biometric devices, as well as assist all of us. How many times a day do you use your fingerprint to identify yourself? My thumb was used to unlock my phone, and my index finger was used to enter my company's building. We know that fingerprint recognition is widely used in our everyday lives. Biometric authentication is highly effective for securing data and other sensitive information because of the uniqueness of biometric characteristics. As we may already know, fingerprint recognition is the most common form of biometric authentication, and the second popular method is facial recognition technology. According to the Spiceworks survey that was conducted in 2018 from about 500 IT professionals from North America and Europe, 46% of companies are using biometric authentication technology on smartphones, which may be influenced by employees bring their own mobile devices for work purpose. Additionally, 25% of organizations report using biometric authentication tech on laptops, while 22% use it on tablets and 70% use it on time clock systems. Door locks controlled by biometric scanners are also somewhat common. And the same report said 74% of IT professionals believe biometric authentication is secure, and 53% agreed that biometrics are difficult to hack than traditional password, but 60% of professionals are concerned about the risk of spoof acceptance. In order to solve these concerns and provide a more secure biometric authentication environment, it is necessary to use an irreversible biometric template and use the match on device framework of the FIDO biometric requirement. And it is also necessary to check usability and security through evaluation based on the FIDO standard. Let's talk briefly about the characteristics of a fingerprint. The shape of fingerprint is a unique pattern of ridges and valleys. The Gelton-Haley class is the most basic method for classifying fingerprint shapes. This method classifies the fingerprint shape into 5 types: the left loop, the right loop, the hole, the arch, and the tented arch. These 5 classes are not evenly distributed. According to Dr. Martoni, the left loop is estimated to be 3.7%. The right loop is approximately 3%. The hole is about 30%. The arch is also about 33%. And the tented arch is approximately 32%. To capture and measure fingerprint, we use several types of sensors. Optical fingerprint capture is typically based on the frustrated total internal reflection technology. When a finger touches the sensor, the light that passes through the glass upon bellies is totally reflected, while the light that passes upon ridges is only partially reflected. Then the reflected light is focused by a lens onto a camera and the fingerprint image is captured. Ultrasonic fingerprint sensor is based upon a pulse echo imaging due to the reflection effect of various impedance of human finger. After a finger is placed on the sensor, a pulse wave with a narrow beam is launched from the sensor. Due to the acoustic impedance of human tissue is much larger than air, the reflection ratio is much larger at the interface sensor. Among these fingerprint sensors, a capacitive fingerprint sensor is most widely used in consumer electronics because they are fabricated using CMOS technology. The finger is molded as upper electrode of the capacitor and the metal plate in the sensor serves as the lower electrode. These 2 electrodes are separated by the preservation layer of the silicon chip and air. Sensing technologies such as summer fingerprint sensor and the pressure fingerprint sensor existed in addition to these 3 technologies. By the way, the difficulty of the biometric performance test is that it has to recruit a large number of people, and this difficulty has become extremely difficult due to the COVID-19 pandemic situation that we faced. So we tried to make prosthetic fingers. Our goal was to create a prosthetic finger that could replace a real finger and use it for biometric testing and evaluation. And it should be applicable to all sensing technologies. Nowadays, in Korea, living in the city is getting more expensive. Especially here in Seoul metropolitan area, price per house is extremely high. So I would like to introduce TTA's fingerprint apartment. There are about 660 households in this apartment, and currently 10,800 prosthetic fingers are living. There are only about 50 cells left. If you want to move in, please contact me. You are welcome to move in for free. The prosthetic fingers shown here are not perfect, but they are good enough to spoof the fingerprint sensors. These are all made of different polymers, and the more we look into it, the more we realized it was about material science, not the information communication technology. Even when polymers are used, there are still issues that cannot be resolved. Another issue is about moisture. Captured fingerprint images may vary different depending on the elasticity and the moisture of finger. When the finger is completely wet, the belly is filled with water. And because water interrupts light and alters impedance, the fingerprint is becoming unrecognizable. This is also true for capacitive sensors because water is a conductor. It was impossible to recreate shape changes in prosthetic fingers, such as the moisture content of human skin, by making polymers. Therefore, we are researching a model that can predict the changes of the fingerprint shape based on the changes in the moisture level of the fingerprint. To begin this study, it was necessary to identify the factors that influence fingerprint moisture level. So we did some more research. I am a researcher by my profession, but I normally prepare to read some papers and attend conferences and learn some interesting things from other outstanding professionals rather than doing it by myself. Doing one's research is always painful. Human skin characteristics such as moisture, elasticity, and capacitance have already been extensively researched into the medical field. However, no research result for those characteristics were discovered on the fingerprint surface. The goal of this additional research was to observe the correlation between fingerprint skin moisture level and environmental conditions, and also to observe the correlations between fingerprint skin capacitance and moisture and the skin thickness and color. We recruited over 600 test crews to measure various characteristics, with 20 staff members participating over the 1 month. And the final outcome is shown in this slide. Although skin on the fingerprint surface is very thin and hairless, our study confirmed that it has nearly the same characteristics as other skin on the human body. The Pearson correlation coefficient for moisture and elasticity is close to 1. This indicates that the two characteristics have a strong positive linear relationship, and moisture, the capacitance, elasticity all had a moderatively positive linear relationship with R values of 0.3 or higher. So, what about the future? What we have empirically confirmed may be just confirmation of the obvious. Just obvious. This knowledge and experience, however, will be extremely useful in the performance test of the fingerprint recognition devices and evaluation of presentation attack detection function. Furthermore, it has been demonstrated that this method cannot completely replace human fingers. So, how should future biometric testing be performed? I think it's AI, the convolutional neural network, for example, can be used not only for liveness detection, but also to generate a data set for performance testing by generating a synaptic image. In this regard, I believe that if my core technologies are researched at universities and an accredited laboratory such as TTI conducts validation studies on the proposed method from various universities, then a simple, stronger, and fast biometric test methodology will be developed soon. This is the end of my presentation. Thank you. Thank you for your time and thank you for attending and thank you for watching. Stay healthy.